Hi, I'm Jessica, and this is my project for ES50, Intro to Electrical Engineering. My project is a motion detecting skirt that lights up only when you move. My project uses the Flora version 2 wearable electronics platform powered by a 3.7 volt lithium polymer battery, a LilyPad Accelerometer, and 8 NeoPixels or chainable miniature LEDs, all sewn together on a skirt using conductive thread to create a light show controlled by motion detection. I first started this project by testing how the accelerometer in NeoPixels worked using alligator clips, my computer, and Arduino code. It took me a while to figure out which pins to connect to, which is why this process was critical before I sewed everything onto the skirt using conductive thread. Afterwards, all components were sewn onto the skirt and connected using conductive thread. The accelerometer is pinned to 5 pins of the Flora microcontroller, the positive terminal to 3.3 volts, negative terminal to ground, and the X, Y, and Z axes to analog pins 9, 11, and 7 respectively on the microcontroller. The NeoPixel chain is made up of 8 Flora and LilyPad NeoPixels and is connected to 3 pins of the Flora microcontroller, the positive terminal to VBAT, which is unregulated raw battery voltage, negative terminal to ground, and the input pin of the first NeoPixel of the chain to digital pin 10 on the microcontroller. Each NeoPixel has a data in and data out pin, and the chain is created by connecting each data out pin to the next NeoPixel's data in pin, and by making sure all of the positive terminals for each NeoPixel is connected to VBAT, and all of the negative terminals are connected to ground. The purpose of the VBAT pin is to provide additional battery input other than the 150 milliamps available from the onboard regulator. The project is powered by a 3.7 volt lithium polymer battery. Made for e-textile projects, the battery cuts off in the range of 240 to 380 milliamps, providing enough power for the NeoPixels, as well as a safe option for electronics sewn into pieces of fabric. Using the Adafruit NeoPixel library, I was able to read the values along the X, Y, and Z axis of the accelerometer to control the lights based on different movements. I played around with various versions of the code to control the lights based on each axis. I ended up setting one color for each of the axes, purple for X, green for Y, and orange for Z, but you could program any light show to start based on how you could move in the skirt. I previously found the difference between vectors calculated using the 3 axes values based on each sample reading. This change allowed me to program 3 light sequences versus 1 per axis versus 1 overall, and was based on inspiration from the course's teaching staff. I implemented this change after the project presentation and Q&A session and decided to display 1 color per movement along each axis, purple for X, green for Y, and orange for Z, and no color when the person is not moving. Hope you enjoyed hearing about how I made my ES50 project, a motion detecting light up skirt made up of an accelerometer and NeoPixels. Thanks to the Adafruit Flora Sparkle Skirt design, ES50's teaching staff, SparkFun, and my parents for the inspiration and support in making this project.